Currently, the Indian subcontinent is reeling under the effects of a deadly and kind of historic heat wave that has persisted for about 6 weeks now, breaking records for maximum temperature highs in both March and April. These months recorded the highest temperatures ever since 1901, when record keeping began in the subcontinent. Rajasthan and Madhya Pradesh have been worst affected directly by the heat, while wildfires have ravaged states like Uttarakhand. While heat waves are indeed expected this time of the year, the severity and intensity of this wave and how early it occurred has been worrying scientists. How did such a prolonged heat wave occur and why? How much of it is because of climate change? Let's have a look at what caused the heat wave in the first place. The current heat wave has been going on since March. The Indian Meteorological Department defines a heat wave as existing when weather stations in the plains measure above 40 degrees Celsius or hill stations measure above 30 degrees Celsius and average temperatures are over 4.5 degrees Celsius above normal. There are other criteria as well. If the current temperatures are between 4.5 and 6.4 degrees above average, or if the actual maximum temperature is over 45 degrees, either persisting for at least 2 days, it is considered to be a heat wave. If temperatures hit over 6.4 degrees above average, or the actual temperature exceeds 45 degrees Celsius, both again for 2 days, it is defined as a severe heat wave. April-May is when the subcontinent experiences heat waves, and May is in fact when heat waves peak. But this heat wave started in March, much early in the season, and persisted through it. This is highly unusual, but increasing changes in climate seems to show that these kind of anomalies are indeed becoming the norm. Last week, stations in India crossed 45 degrees Celsius, while stations in Pakistan crossed 47 degrees. With just the Indian subcontinent heating up so much in the last 2 months, over 1 billion people have been experiencing ungodly levels of heat. How did this heat wave form in the first place? There are two phenomena that are the primary drivers behind this heat wave. One, of course, is climate change, and we'll look at it later. But the first one to look at is La Nina. La Nina and El Nino, which means the girl and boy respectively in Spanish, are climate patterns that occur in the Pacific Ocean and affect weather globally. Under normal conditions, trade winds in the Pacific blow west along the equator. These winds move warm waters from South America to Asia. As the water moves, cold water from the bottom rises up near the Americas. This happens seasonally. La Nina and El Nino interfere with this normal annual weather pattern. They occur anywhere from 2 to 7 years and last 6 to 12 months. These are natural climate patterns that occur in the Pacific Ocean. During El Nino, warm waters are pushed from Asia to the Americas, and during La Nina, trade winds are very strong and push warm waters from the Americas to Asia. Near the Americas, more cold water rises up during La Nina, and this ends up pushing the jet stream or the wind currents more towards the north. So during La Nina, waters near Asia are warmer and waters near Americas are cooler, and El Nino has the opposite effect. This La Nina cycle began somewhere about October 2020. Overall, in the past 14 months or so of La Nina, the Pacific Ocean is cooler, but the warmest waters in the ocean have been near Eastern Asia and Australia. So while we here in the subcontinent are getting baked under this heat, Argentina is receiving record snowfall right now. In La Nina conditions, winters are colder with cold waves and monsoons are more intense. These conditions have persisted since October 2020, and let's also keep in mind that in general La Nina is also getting warmer than usual. These warm waters near Asia with warm surface temperatures blow northwesterly winds towards the Indo-Gangetic plains. There are now also hotter winds coming from Pakistan and Afghanistan, and the pressure pattern that is persisting over the waters because of La Nina conditions is also pulling in warmer winds from the Arctic. All of this is converging towards the Himalayas and in India towards the Indo-Gangetic plains because of the mountain ranges. But what has caused the heat wave and what is the wave in the heat wave? Now remember the jet streams, the bands of winds that blow around the planet. The ones that blow over India at this time are the subtropical westerly jets belonging to that jet stream. These winds are now blowing over northern India. As these winds blow, sometimes they encounter pressure disturbances and other hurdles, and they can in fact flow like an actual wave. Imagine the equivalent of a tsunami rising from calm ocean waters. This wave that rises creates a ridge or a crest of the waveform within the jet stream. So, over land, the winds are much higher in altitude than where they usually blow. As a result, there is a high pressure condition that is created at the top layers of the atmosphere, and this in turn traps all the air below from all sides because it's a crest of a wave. This effect plays out in the form of what is known as a heat dome, with strong and high pressure conditions from the top acting like a lid and compressing all the hot air, literally creating a pressure cooker like situation. The flowing winds at the top of this dome move all the hot air to the east. The jet stream traps the air, but this encounters the rest of the jet stream, which traps the air and causes it to sink. This sinking air is hot, and this hot air that sinks results in what we describe as a heat wave. Because there is high pressure all over the subcontinent, other circulation patterns are also not being pulled in, which could potentially cool this region. The northern parts of India and Pakistan have seen incredible new highs of temperature records being broken. Over the weekend, cities in Pakistan hit 49.5 degrees Celsius or over 121 Fahrenheit, and Indian cities in UP recorded upwards of 47 degrees Celsius or 117 degrees Fahrenheit. Depending on local weather conditions, the heat can cause cascading effects differently. These kind of intense conditions can interact with moisture and humidity in two ways. The effects of a heat wave in a humid place is very different from the effects in a dry and arid place. In the northern part of India, humidity dropped with less precipitation than usual. This dryness combined with the heat wave has led to a precipitous rise in forest fires. Over 100,000 forest fires, over 1 lakh forest fires were reported this year between January to March alone. There is general loss of moisture and humidity, and animals and humans get dehydrated in these conditions. The eastern states and the coastal states, on the other hand, have high humidity. In places with high humidity, it is hard to cool down through sweating because the sweat is not evaporating. High temperatures with high humidity is deadly and leads to overheating. This can be quantified by something called the wet bulb temperature. A wet bulb temperature, or WBT, is measurement taken with a thermometer that is covered in a wet cloth and has air passed through it. It can actually record high temperatures even when the actual atmospheric temperature is cooler because, let's say, it basically measures how well a person cools. Even people who are well suited in living very hot conditions, heat adapted people, can tolerate only a certain level of WBT. They cannot perform regular outdoor activities or manual labor in wet bulb conditions of over 32 degrees. Beyond wet bulb temperatures of over 35 degrees, humans cannot survive. Last week, some parts of Odisha and West Bengal measured wet bulb temperatures of 29 degrees Celsius. Even nighttime temperatures did not come down naturally, which prevents us from cooling down. India experienced really high WBT temperatures in 2016 as well. 19th of May 2016 is actually the record holder for the warmest recorded temperature in the country, hitting 51 degrees. But as a trend, we can see increasing temperatures in all kinds of readings steadily with each passing year. While this heat wave was triggered by La Nina and jet streams, the intensity of the heat wave has definitely been worsened by climate change. As the world around us heats more and more, land and sea surface temperatures rise, messing up temperature and pressure gradients, and thus also wind and ocean current patterns. Land temperatures over India and Pakistan climbed upwards of 60 degrees Celsius over the weekend in some parts. This alarmed a lot of people, and for good reason. However, there's a little bit of distinction. Land surface temperatures are different from air temperatures or atmospheric temperatures that we usually measure. Land temperatures are measured by satellites, and land retains much more heat than the atmosphere does. We know that on a hot summer day, it is extremely difficult to walk barefoot on any kind of surface. Compare that with just exposing our faces to the air at the same time. That's the difference. Land surface temperatures always measure much higher than atmospheric temperatures every year. That said, the temperatures during this heat wave so very early in the season have actually been alarming. While some respite from the heat wave is now expected over the next few days, it has indeed been a dire sign of things to come. Many bits of research have projected a global increase in heat waves, and India-specific studies have also found the same. Along with this, fatalities that are associated with heat waves and heat-driven events are also going up all over the world. Heat waves also have long-term health effects. The inability to cool at night makes our bodies prone to overheating, and this problem is worsened in major parts of India where so many people live without access to air conditioning even if they desperately need one. After this terrible ordeal, the heat wave is now passing over, and now the Indian subcontinent is primed to experience its peak summer.